Okay, good morning. We're going to go over the unit study guide one more time, and this time we're watching a video to do it. And just be familiar with all of this tonight. Learn all of the basic formulas and the definitions, and be familiar with the words that you might see. And the best way to do it is to tune in to the basic definition of each one. How far around something. So words like borders, fences, walls, frames, those would be clues to, oh, okay, that means we're going around. And to do that, that would be adding all the sides. And then don't forget to label properly. So you would just put the unit measurement of, well, what's the units that we're measuring with? That would be, for this one, it's inches. But just be careful of what it is that you're doing. For area, it would just be slightly different. You would be square units, and what are the units? They're inches for this one. And so just be aware of those basic things and be familiar with it. Okay, so now let's just go over again. If there's any work that you didn't do before, just take note of it. Any parts that you might have not underlined or highlighted, go ahead and highlight. Like, oh, there's that word highlighted. This word's highlighted, have it in bold black. So those would be words that you would typically underline or whatnot. So see this part right here, you're definitely going to copy this and go from there. Remember this part we already talked about. Go ahead and copy this if you didn't write this before. Pause the computer and copy that so you have a little bit of a clue. And don't forget to use your calculator to calculate these numbers. Also notice I did a quick little check. I rounded this to 10 and this to 20. That would be 200, and then divide by 2. So then it would be roughly 100. So then it would be easy that I would choose this one. And I wouldn't choose this one because it's the wrong label. Because like we were looking over here for labeling an area, it's whatever the number is, square units. And the unit of measurement is, for this one, would be centimeters. And for this one, it was also centimeters, so it would be square centimeters is what they want because it's area. So then you're measuring the inside of, in 2 dimensions, inside the item that we're doing, not going around. So that's why it's called square. That's why it's called square centimeters. Okay, and go from there. So there's that. And likewise, same here. You're finding area for a square. They only give you the measurement for one. I did another one because as you look right here on this example here, we have square, and it's gives you one side, and we just remember that a square is like a rectangle. They're both rectangles, and they're made up of nothing but right angles, and they have a length and width that determines the area. So we only have one side here, but we know all sides are equal. Doesn't mean we multiply all 4 of them, just multiply 2 of them, because that would give us a length and a width of this particular rectangle, which we call a square. And don't forget to label it properly, whatever its square units are. And the units in this case for this one was inches, but for this one it is centimeters. So then it would be square centimeters, and that's why the correct answer would be this one right here. But I could easily had another answer here that said 4,900 centimeters, but you want to choose that one. Okay, now let's go over one that we didn't do before. So you might want to pause and look at some of the stuff that I wrote here. I circled this number that's important, and this number, but also this part. So I might highlight this and highlight that, and you can pause to do that and copy all of this other stuff. So you can do that right now and pause. Okay, thank you. And also, as you notice, why all this information? I took note that I needed perimeter, and I took note that I needed area. So then I remember what it is. I checked my formulas right here, and I found that that's at all the sides, and then area is length times width. So then I calculated, and I got 7 plus 7. But remember, it's not just these 2 sides, because that's the length and the width, but there's 2 lengths to a rectangle. Or in this case, this is a square they're describing. There's this length, the length, and then there's the width, but then there's another length and another width. Okay, so then you would add all four of them together and you get 28. So you might be tempted to be like, oh, that's the correct one. But the rectangle that we're looking for is a rectangle that's 28 millimeters, but also has an area that is that. And since it is a square, we only take two sides of it and multiply them. 7 times 7 is 49. Is that the one we're looking for? No, we need one with 24. And obviously, it's down here is the correct answer. But if we were doing this one at a time, you would have calculated each one separately, and this would be 7 plus 4 would give you only part of half of the rectangle because we only have one width, and there's two widths, and there's two lengths. So then we would take the two together, and then we would do 7 plus 7 is 14, plus another 4 would be 18, plus another 4 would be 22. And that's why, oh, wait a minute, that one's not it, so cross that one out. And the same thing happens when you do this next one. When you do this next one, you're also going to have the same problem. You're going to have 8 plus 3, and that's going to be 11. And then you're going to do it a second time, and that's going to make it 22. Uh-oh, not correct. Even though the area is correct, 8 times 3 is 24, so that's correct, but the first one, perimeter, isn't. So this is one of those problems that you want, and there's problems like this on the SOL where you could easily get them right, and there's a lot of them that are like this, but they're double step, triple step. This one is like a lot of steps because it's like 2 steps to do this one, 2 steps to do that one, 2 steps, 2 steps, and there's 4 answers. So that's 8 steps here. So another thing to remember is using your calculator. Notice I could have done a lot more work, but I maintained some of it in my head because I knew I had to add all sides. So I didn't just do 7 plus 7 and be like, oh, it's 14. No, I remembered that there's several sides. I could ask for another piece of paper and write all of the work, so you can do that. You can minimize it if you can hold it in your head, but please feel free to ask for more paper. We will give it to you. All right, I will give it to you. And on the SOL achievement test at the end of the year, we'll give it to you if you need it. So please ask, and we'll give you more lined paper. We'll bend over backwards to give you more paper to show your work. So that's fine. But please make sure that you have at least this. So pause and do it if you didn't do it before, and make sure that you copy everything that you're seeing. We already talked about this one. Here's the information. Just don't forget the labeling. It's always cubic units. And in this case, it's going to be cubic meters because they're meters. And there's 3 dimensions. That's why it's cubic. Okay? And that's why you would not choose this one as your answer. You would choose this one. Okay? So the next one, we also already did this one. So just underline these words because when you would go through the study sheet, you would have done that normally. But obviously, you're not going to have that on the test. But for work, underline the clues that helped you realize it was that. So when you finish the test, the actual test on Tuesday, and you hand it in to me, and these won't be in the same places, so don't be like, oh, okay, the first one goes down to the middle, and this one goes up here. No, it's gonna be mixed, so it's not gonna be the same as this one. So please, for work, you're gonna have to show me, underline a word that gave it to you. Write a word here that helped you. So please copy this, even write that, because these are examples of clues that you would get. For the one, Mr. Mahalchek one, we already figured that one out as a class. But underline this word. Underline that word. And then that's why you chose this one, because volume, a fill is a word. Around is a clue that helped me to realize that it was perimeter and not volume, and so on. We could underline carpet, because that would be a clue that it was area and not volume. Not like that one, and then so on and so forth. All right, now let's look at the next one that we did. So we have number 8. Number 8, we have area. We look back, highlight that word, underline it, look up the definition of area, write 2-dimensional. It has a cover. Okay, then look at D. You found the word cover, so that's why we underline that. I even underlined tarp because I remember what tarp was. It was covering. So just copy this. Copy what you're seeing right here. Number 9. You go back and you see that perimeter refers to going around, or you think about it in your head and say, oh yeah, perimeter means measuring around. So write around here, and then, oh, I found around. Underline it and circle this is your work. You didn't show an equation because it didn't need an equation. Didn't need to tell you to add or multiply or anything. Just we needed to identify which of these tasks would definitely be a perimeter task. And this is definitely a perimeter task because we're going around. So again, maybe we have a certain size fence already. We just need to know how much of that certain size fence we're going to need. And so we're finding perimeter. It's basically what we're doing. Okay, this one right here, kilometers, here's where we added something here to our study guide. So please take time to copy this. So this is new, something I added. So then please write this in your notes. This would be something to remember for later. This is the only problem that has to do with kilometers, and they want us to convert from kilometers to meters. So really, it's only km times 1,000 that we're thinking about right now to get to meters. But please copy this down too, so because you remember if you have a whole bunch of meters and we want to go to a larger unit, that means there's going to be fewer of them. So it's going from a very large number to a small number. But if you're going from kilometers, just a few units, and you want to go to see how many meters would be in each of those kilometers, then that's why you would multiply. So let's look at that right now. So we have right here, we have 1 kilometer, and you can please copy these notes, times 1,000. Okay, and notice that there is 3 zeros more. So what did I multiply? I multiplied by 1,000, and that's why this became this. And in this case, 8. So 8,000. I mean, it makes sense because you're multiplying here. It increased by 3 zeros, it increased by 3 zeros. But here's a thought to think about. You could think, well, I could just add 3 zeros to it. Well, actually what I'm doing is I'm going 3 place values up. When you multiply something by 1,000, you're going 3 place values up. You're not just taking 3 zeros here and putting them up against 8, because what if it was 8.4? You wouldn't add just 3 zeros and call it 8.4000. No, you would actually move that decimal over. So here was the decimal, it was here, then it moved. And in that case, it wouldn't be 84,000. It would be 8,400. But this isn't 8.4. This isn't 8 and 4/10. It's just 8. So it moves 3 place values over, and it becomes 8,000. So that's one way to do it. Or you could just multiply it using the calculator and just remembering this process that. And this is on the test. They'll remind you. So I'm assuming that since these main district tests are like this, that the assessment test at the end of the year is also going to be similar. They're going to give us a little bit of a clue. They're not going to tell us, hello, you need to multiply, but you can see it, that it's 1 here and there. And so if this decimal part of moving the decimal isn't working for you, please do this part. But as far as I'm recommending right now, please copy this, because maybe it'll stick eventually if you do it enough times. But also remember this part, and remember to write this part down and that. Okay, so same thing here, same thing. You go back to your study guide, and you're going to look up, this time you're going to look up liters and milliliters. And we have liters, and then it's times 1,000 to get to milliliters. And if you want to go from milliliters to liters, it's division. So let's see what they want us to do. I wrote some notes already, and I assumed to go to also to multiply. But notice that the numbers are in a different place. It doesn't matter where they are. The same thing. They're just telling you the smaller unit first, and that there's 1,000 milliliters in a liter. They could have easily just said there's 1 liter equals 1,000 milliliters. It's the same difference. So no matter what order they put it into it, just think about the fact that a milliliter is these little tiny caps full of water, and then and a liter is basically a smart bottle of water, 1 liter. So that's the difference. So you could just commit this to memory and be like, oh, wait a minute, it's 1 liter converts to this many milliliters, and they say how many milliliters. They want a large number. They have a small number here, but they clearly want a large number because they start off with a large unit, and they want you to go into smaller units. And just like if you had 3 feet, we know that it would go into smaller units, and that would be 36 inches. You know, the number is going to get larger. The unit is going to a smaller unit, yes, but then there's going to be more smaller units. There's going to be a lot of them. And in this case, there's this many smaller units. There's 1,000 smaller units equals 1 liter. So then it would be 3.2 times 1,000. And like I said, it wouldn't be just 3000 or 320,000. That would be 32,000. No. And best way, if you don't get to move the decimal, just multiply using the calculator. But please copy both of these so that you can learn this slowly. You'll learn that you're moving the decimal 3 place values when you're multiplying by 1,000. You're actually moving this dot to the right 3 times underneath the 2 and then underneath 2 more times. And you base that based on the number of zeros that are in this multiplication of 1,000. Okay? All right, next one is we go really quickly. We have 1 kilogram equals 1,000 grams. A container weighs 5,000 grams. What is its weight in kilograms? So they want us to go from the smaller unit this time to the larger unit. So then again, I refer back to my notes or to the study guide sheet here, and I go, oh, okay. So then I write this amount, write that, and that's a reminder. I write a little note here that, oh, okay, wait a minute, I'm going from the smaller unit to the larger unit, so there's going to be fewer of them. So I'm going to get a small number. And now what is it? It's 1,000. It's 1,000 grams in a kilogram. So then it would be 5 divided by 1,000. Copy that, copy this, and then be like, oh, and then when you do that, you get 5 kilograms is what you get. And I don't see it here, so I scratch it out. Don't see it here. Move on, do the next one, and finally I find it. It's right there. Okay, same thing for this meters one. You can pause it at any time and copy this, because we're just trying to grasp the basic information here. So just copy this information, okay? So then you notice that it's going, again, it's going from the smaller unit of 24, and we need to go back to meters, but it takes 100. So 100 to make a meter, so then that means we're gonna be in a decimal. So there's 2 decimal ones. It's definitely not 24. It's definitely not D either, because that's 2,400. We're going to get a smaller number because we're converting it back to meters, and we don't even have 100 centimeters when we have only 24, and we're going back to meters. So it's either going to be this one or this one. Now I chose this one. How did I choose it? I chose it by remembering the equation, because here it's division by 1,000 when you're going centimeters to this. So just take the number we have and divide it by, not 1,000, by 100, and divide by 100, and that's why we get this particular number. Okay? All right. Now, Mrs. Clark is making Halloween candy bags for each of her students. She needs 13 centimeters of ribbon to decorate each one. She purchased 5 meters of ribbon. How many centimeters of ribbon will be left over after making the bags? 1 meter equals 100 centimeters. Write your answer in the box below. Okay, so you can see all this information, and notice I wrote a step 1. Step 1 is I'm figuring out what do they want me to do, and I highlight or circle or underline the things that are obvious. Well, they're saying a number called 24 students, and it says that she's making candy bags, plural. Okay, she needs 13 centimeters for each, but they're making several of them, so it's not just 13. Why would she buy 5 meters if there's only 13? Because a meter is 100. Why would I buy any more than just a meter? I wouldn't buy any more than 3 feet of because that's what a meter is. It's basically about 3 feet and a little bit more of ribbon. Why would I buy tons and tons of it? It's because there's more here than just what you think. So remember, it says each. So that's 24 times 13. There's a grouping. These students, each one of them is getting 13 ribbon. And the 13 centimeters is only this much. It's only that much. And then we're wrapping it around in a cute little bow, putting it on a little bag, maybe making a ghost. And that is your Halloween bag. And there's 24 of them. So that's why we're talking about in the hundreds of centimeters for this. And so let's multiply 13 times 24. Use our calculators. Make sure you write down what you're doing. Please write it down. And what does it equal? It doesn't equal that, by the way. It equals 312 when you multiply 24 times 13. Where did I get the 500 from? Remember, we have to take it away from the total amount that we have. And 5 meters, copy this, please. And that's 5 meters times 100, because each meter equals 100. So that's 5 times 100 equals so many centimeters, which happens to be 500. So she has 500 centimeters, because we can't subtract until they're the same numbers. And we got a big number of 312 centimeters. We put the 312 right here. And then we have only 312 centimeters. And so then we subtract it from that, and we get 180 centimeters. Okay, so the next one, how did we get these answers? Please highlight this information and underline the words that I did. I underlined this one because I noticed that I had 12 kilograms, and then all of a sudden, because I had a piggy bank with coins in it, and it weighed this much. But then I took the coins out and I weighed it again, and it was 900 grams. But I can't subtract these two until they're the same amount. So I chose to convert both of these to the same amount. And so what did I do? I obviously changed this. And how could I do that? Well, I changed it from grams to kilograms. There's 3 zeros here. So then what would it be without the 3 zeros? 9. So it's 12 minus 9 is 3 grams. Okay? And 3 kilograms, not 3 grams, 3 kilograms. So I chose this one. But it says circle all the correct answers. So now, great, I got kilograms. It can't be this one because it's this one. This is, remember, a kilogram is 2.2 pounds. Your piggy bank is only 3 times 2.2. So that's 6.6 pounds is all that your piggy bank weighs. It does not weigh, this is way more. This would be ridiculous. This would be 6,000 pounds we're talking about. And no, your piggy bank does not weigh 6,000 pounds. It doesn't weigh 3 times a car. Okay? So let's use our noggins here, and we're only choosing this one, but there's one up here to choose. So we need to remember how to convert. So we go back up here, and we have 1 kilogram, and obviously we multiply times 1,000, and we got 1,000 grams. So we do that here. We times 1,000 and write this. So please copy this information, and then that's how you got these 2 as your answer. And so please remember this process, and remember to convert. Remember that you might be doing different steps, like subtracting when you're removing. Actually, I think both of the problems you're just going to be taking away something. So try taking away, but make sure you take away with the measurement. You have to make sure both measurements are the same. Okay? Just like we were up here, you have to make sure that both of them are centimeters in order to do the steps. Okay? And then you go to the next part and do the next one the same way. Okay? This one, though, is milliliters, and this one, you have different people with different amounts. Maria has 350 milliliters, Sally has 800 milliliters, Bob has 680 milliliters, and Tommy has 825 milliliters. How many liter containers will be needed to hold all the water? 1 liter is 1,000 milliliters. Here they go again, telling us the information. Notice that I said division right here. I said divided by 1,000. Why did I say that? Because I'm going from this small unit where there's a lot of numbers, and this is going to come out to a big giant total, and then I want to go to a larger unit, and so this number is going to be really small. That's why it's going to be only 2 liters, or only 3 liters, or only 4 liters, or only 5. Why did I choose 3? Well, if you add them all together, and I could just round this briefly, I don't even have to actually do it. I could do, this would be 300, this plate 400, 400 plus 800, that's 1,200, 1,200 plus 700, that's 1,900, 1,900 plus, I'm just guessing here, so it's 1,900 plus 800 would be, what would that be? That would be 2,700. And obviously it's a little bit more than that, but it's not quite 3 containers. Well, we're not going to leave any water. We want to make sure that how many liters of containers will be needed to hold all of the water. So that extra 700 milliliters or so, we need to put it somewhere, even if it's not a full container. So that's why we put it in that 3rd container. And that's why we choose 3. Okay, this is just like those remainders where you have an extra remainder, but you're like picking up kids and taking them to the concert. You're not going to leave some of the kids that already paid for the field trip just because you couldn't put 75 students in every single bus. No, you're going to have that one bus with just one one student on it, whatever, because you need to take everyone on the bus. Okay, and here we go. So then we have the next one. So now we're into time. We're into the time elapsed time. So notice how I have all of this information. Please pause and copy things that you might need. Okay, so I'm reading this. A train left Los Angeles at 4:32 a.m. and arrived at Santa Fe at 6:47 p.m. If there were no stops, how long did the trip take? So we're going from this point to this point. How long did the trip take? Well, we know that it took more than 12 hours. How did we know that? Because it's 4:32 a.m. and then it passed 4:32 p.m. and then it equaled this. And this is just something of me deep thinking. So just think deeper about what you're doing and be like, just observe and be like, oh, wait a minute. 12 hours has passed because 12 hours, the 12-hour opposite to this one would be 4:32 p.m. Okay, it's 4:32 a.m. and then 4:32 p.m. would be 12 hours. So this time that we have is more than 12 hours. So we can eliminate right away 2 hours. It's not 2 hours here. Can't be this one. Can't be this one. Okay? Because these are only 2 hours. And we already know that it's past at least 12 hours without even having to do any of this fancy benchmark stuff. Okay, so now we look over here and we pay attention a little bit more. So I have two different ways to do this. One way depends on you, because if I'm going from 4:32, I want to get to the next hour and then go to several hours later, because I know that there's a middle of the day. And the middle of the day is 12 o'clock. So then I would write 4:32, put a line, then I put 5 a.m., put a line, and then I put 12 o'clock, 12 p.m., and then I would put 6:47. Now some people will take 12 o'clock and they'll subtract 4:32. Now you could do that. The recommended way is to do a benchmark like this of some kind. I could do 4:32 to 5 o'clock to 6 o'clock, 7 o'clock, 8 o'clock, 9 o'clock, 10 o'clock, 11 o'clock. I could write them all out. Or I could remember that it's from 12 to 5. Now I could do that kind of simple subtraction. What's 12 minus 5? That's 7 hours. So I would write 7 hours right here, because that's an easy subtraction. I don't have to deal with the change in base, because remember, hours is base of 60 and minutes is the minutes itself would be base of 10, but not when you're taking from the hours. It's 60 you're taking, not 100 to equal to the tens place of minutes. And so that's why I would recommend that you would do it that way. Go from one benchmark of an hour to another hour. So then you would have, well, how much minutes? 28 minutes to get to here, and then 7 hours to get to 12 o'clock. And then after that, you can think of like the British clock and go 000, and then be like, well, how many hours after that in the afternoon? 6:47, so 6 hours and 47 minutes. Stack them on top, 7, 47, 28. It comes out to 13 hours and 75 minutes. But wait a minute, there's only 60 minutes in an hour, and 60 minutes would be 00 anyway. So take 60 minutes out, that would be 15. But then where does that 60 minutes go? It becomes added. So you wouldn't subtract over here, you would actually add, because you took an hour out and you added it back. You gave it back to Grandpa, and it's 13 plus 1, and that's 14 hours and 15 minutes. So I choose this one, not the 13 hours one. But also, I already know it's 13 hours and 75 minutes. So when I look over here, be like, well, it's not this one, so it must be this one. So that's one way to do it. Why did we write this other one? Well, honestly, if you were doing this in class, you could just write this one, or you could write that one. This one is for people that are struggling with figuring out when they're looking at this and they think it's 18 or they think it's 28. They don't know. So then they do a little bit, 4:32 to 4:40. They go to a simpler benchmark, every 10, every 5 minutes, whatever helps them. So hopefully it's every 10 minutes or every 20 or whatever. So then you go 4:32 to 4:40 would be 8 minutes. And then 4:40 to 5 o'clock, oh, that's easier, Mr. Holiday. So that's only 20 minutes. So 8, 20 minutes, still 7 hours, still 6 hours and 47 minutes. And then you would still stack it, and it would still be 7 hours, 6 hours and 47 minutes, 20 minutes, and 8 minutes, and it would still equal 13 and 75, and you'd still be like, wait a minute, it's not this one, it must be this one. And then you can do any fancy subtraction or anything else you need to do. So please copy this down, and then Let's go on to the next one. So problem 18. Problem 18, how much time has passed from 3:37 p.m. until 11:23 p.m.? Here's the first thing I notice. See, I'm taking back time and I'm thinking about how much of the day am I actually using. I'm using less than 12 hours because it's between 12 noon and 12 midnight, and so I'm less than 12 hours. This is important because they're both the same meridian, because now I know that I can eliminate anything that's more than 12 hours. It's not this one. It's not this one. And see, this is a trick because this one would calculate 19 hours and 46 minutes exactly if I used 3:37 a.m. to 11:23. I would calculate 19 hours and 46. So this is a check because questions like this will be on the SOL at the end of the year and on the unit assessment. They're going to try to mess you up by seeing, are you paying attention to the details? Are you paying attention to the details? Okay, so now that we've done that, we would create a benchmark. Now, we've been talking about going to the nearest hour and then benchmarking from that. But here's another trick that you can do. You don't have to worry about benchmarking to 4 o'clock, although you could do that if you feel more comfortable, or you already did this one, leave it if you already showed your work. Otherwise, please pause the computer right now and copy what I've already written right here. Okay, so please pause and copy. Okay, thank you. So then we have 3:37 to 4:37, that's 1 hour. 4:37 to 5:37, that's 2 hours. Okay, 5:37 to 6:37, that's 3 hours. 6:37 to 7:37, that's 4 hours. 7:37 to 8:37, that's 5 hours. 8:37 to 9:37 is 6 hours. 9:37 to 10:37 is 7 hours. So we have 7 hours as a choice. But let's see, does the 23 minutes and the 23 minutes equal something that's 8 hours and 23 minutes? No, because 23 plus 23 would just be 46. So that's why this one is the correct answer, because clearly this is the same meridian, so that's why it's not this one. Notice the similarity between these two. Okay, now we're on to problem 19. So this problem right here, Sally looked at the clock, and the concert was that she was at, so she's there currently, would end at 11:15. How much longer will the program last? One thing you will notice about the clock is I wrote a PM here just to make you to think about it, because most concerts happen at night, so you need to use your brain. So like if they say that there's a sporting event, probably at night. If they say there's a play, probably at night. Are there morning plays? Sure. But if we're involving two times that are in different meridians, they will tell you. So you can imagine that this is AM and AM, or PM and PM. So if they don't tell you a time, a meridian, then just assume automatically that they're in the same meridian. Don't have to ask me, just assume, because you're going to have a question like this on the SOL at the end of the year. You're not going to be able to ask us, well, it doesn't say what meridian it is, so I don't know how to answer this one. No, just do your best, because that's all we can say. But you know that your best is to realize that they clearly must be in the same meridian. So just use your noggin. So then you calculate what time it is, and it's the hour hand is between the 9 and the 10. It's about halfway or a little bit past halfway, because it's almost the next hour. It's almost 10 o'clock, but it isn't. So it's 9 something, 9 o'clock. Then it's 7 times 5 is 35, plus 2 notches, 9:37. And from that, we can build a benchmark. You can make a quick benchmark of 9:37 to 10 o'clock and be like, oh, that's 23 minutes. If you're struggling, benchmark it to a closer unit of 10 and be like, well, there's 9:40. What's the distance? Only 3 minutes. Okay, great. 9:40 to 10. Oh, that's easy. That's 20 minutes. So it's still 23 minutes. And then 10 to 11, that's 1 hour. And 11 to 11:15, that's 15 minutes. And when you add that all together, 15 minutes plus 23 minutes, use your calculator. That's 38 minutes plus an hour. So then you have your choices. You have 38 minutes. Well, it's not that. We said an hour and 38 minutes, so don't just choose that because it says 38 minutes. Look to see on the other page if there's any more choices. And there is, and that's the one that it is. And we know it wasn't these because it's a concert, and most concerts only happen in one part, and they would have said AM to PM if they wanted a larger one. So even before we even started doing this, we could have actually looked at all of our choices. Look at all of our choices right now, and then just automatically eliminate these, and then we would have had 38 minutes and this one left, and that's it. So now let's go on to the last one of problem B. Let's see if we can get it clearer here. Here, let's see if I can move to a brighter space here. Okay, so this hopefully this is a little bit clearer. So now you can see right here we have the table below shows the hours each of 4 stores are open for business. Which stores are open for 9 hours? Put an X to all correct answers. And so you can see what we already chose, but don't just take our word for it. I want you to copy this information and see if you can't realize where we got this information. So the first one, Henry's electronics store, is 7:35 a.m. to 5 p.m. So then we look at the information and go like, oh, wait a minute. We have 7:35 and we go to 8 o'clock and figure out how much that is. If this doesn't work for you, again, you can benchmark to 7:40, and that would be 5 minutes, and 7:40 to 8 o'clock, that would be 20 more minutes, so that's 25 minutes. And then from 8 to noon, remember, use noon as a benchmark. Use noon as a benchmark, and then just go there and then be like, how many hours between 8 o'clock and 12 o'clock? You can subtract that easily. So anything in the morning you can subtract, but then anything in the afternoon you just add. So it's 12 minus 8, well, that's 4. That's 4 hours difference. Or you can just figure it out. 8 plus what equals 12? Oh, that's 4 hours. Okay, great. And then you could think it the British way at this point and think 00 plus 5. Oh, how many hours is that? 5 hours. I made a mistake right there. But just add another 5 hours. So then it's 4 plus 5 is 9 and 25 minutes. Did I make my goal of being open exactly 9 hours and 25 minutes? Yes, so I mark X for that one. And again, this one's a different time, but it still could be the correct answer. So go 8:15, and then I'll look at how I benchmarked this one. I chose to go to 8:30 because maybe it's harder for me to realize, oh, there's 45 minutes to the next hour. So I'm just going to go from 8:15 to 8:30 and be like, oh, that's 15 minutes. I understand that. That's 15 minutes, so that's, okay, perfect. And then it's 8:30 to 9 o'clock. Oh, wow, that's easy. And so then that's 45 minutes right here. And then I have 9 to 12 would be 3 hours. And then I cross out this, put 000 plus 5 hours and 40 minutes. And that's 3 hours plus 5 hours and 40 minutes plus 30 minutes and 15 minutes. That equals 8 hours and 85 minutes. Now, I can't possibly have that. So then we're copying down all this information for holiday for me. And that's 8 hours and 85 minutes. And then I know that I want to eliminate to figure out what real time this is because I can't get 85. So take an hour out. How much is an hour? 60 minutes. So 85 minus 60 is 25 minutes. And what did I do with that hour? I add it back to 8. And that becomes 9 hours. And it becomes 25 minutes. So did I make it? Did my store open exactly the same amount of time as Miss Henry? Yes, it is. So then I'm also put an X by mine. Now, notice Bailey's. Bailey's starts exactly at the same time as mine, but it lasts a whole extra hour than me. So I already know it's wrong. So I could just put wrong here. It's 1 hour more than Mr. Holiday. You could write that. That could be your only work, 1 hour more than Mr. Holiday. So you don't have to say this. But what I wrote here, if you want to copy it, is simple. It goes 8:15 to my time, the same time that I'm open till, and just make a comment, 9 hours and 25 minutes. I've already done the math for it. Then plus another hour, and that equals 10 hours and 25 minutes. It's open longer than the other two so far. So just, then you can just cross it out and be like, oh, I'm done. And then the next one, but please, if you're having difficulty, please, and also if you're not, please copy all this information so you have it down. Okay, and then Brucker she starts later, but according to this, she makes it. How does she make it? Well, she's open longer, so maybe the numbers can work out. So 9:30 benchmarks to 10 o'clock, 30 minutes easily. 10 a.m. to 12 noon. Remember, use that benchmark. Always use that benchmark. It's a good rule of thumb to go to the midday because then you could just subtract 12 minus 9:30. And if you can't do it that way, just benchmark to 10, and then 12 minus 10 is easy. That's 2. Okay, so that's one easy. Or add up. 10 plus what equals 12. Boom, 2 hours. Then you can reset it to the British clock, put 000, and then how many hours after that? You're just adding. So then it's 6 hours and 55 minutes plus 2 hours plus 30 is still 8 hours and 85 minutes, just like up here. So then you would convert, or you can leave it because you know it's going to convert to the same thing, 9 hours and 25 minutes. So then boom, I got the last of part A. So good so far. Now we just have two other big problems, and that's part A. So part A is where you have the big opus of everything we've already been covering in part B. So on the test, you're going to do part B second this time. So instead of us spinning and pouring out our whole effort on part A, we're going to pour it out on part B, which will be easier problems. And then when you get to this is going to be easy peasy because we've already gone over all of our equations already. So we would go back, take out our equation paper, because they want to know the volume. Well, you can refer to it in your study guide, but remember, you're not going to have your study guide. So when you're studying tonight on Monday night, and you're studying for the test for Tuesday, all you can do is be familiar with what volume is, and you're multiplying these dimensions. Now, they made this one easy, but I've seen them on different things, on test samples, where they put a few extra measurements. They might put 12 feet here, they might put another height mentioned here, but you're only going to have to circle, because they ask you to circle here, you're only going to circle 3, one of each type. Don't circle 3 4 feet. Make sure it's 1 4 foot, 1 5 foot, 1 12 foot, one of each type. See, one's an up down, which is height. One's a side to side but small, that would be width. And one is a side to side long, that would be length. And so one of each of those dimensions. And so when they ask you, how did you figure it out? Well, length times width times height. That's how you figure it out. I multiplied one of each dimension. So please copy this to commit it. So when you multiply it, use your calculator. Don't try to show off and impress us. Just use your calculator. Calculate this information using your calculator. It's going to tell you 240, but that's not the complete answer. You need to have it labeled properly. And so just remember that labeled, since it's 3 dimensions, it's like what you're basically doing is I can fit 250 foot by foot by foot cubes inside of this box. So if I had a box and I made it go 1 foot one way and 1 foot another and then 1 foot up, it would equal 240 cubes that are foot by foot by foot, and they would fit perfectly in this big giant storage unit easily. So please make sure that you label it properly. So that's all you have to do for that one. That's very easy. Okay, and here's the last problem. So this one, it's nice because it's teaching us also about the relationship between rectangles and triangles. Because to make right angle triangles, all you have to do is subdivide a rectangle or a square. So that's easy. So subdivide the rectangle above into 2 triangles. So you're going to take your paper and put a line from an upper corner to a lower corner like this, that's diagonal. You're not going to go straight down, but you're going to go diagonal. And that will make 2, more or less, they should be, 2 triangles that are exactly the same. So then it says label one of them A and one of them B. Find the area of the right triangle A. It doesn't really matter because you could say this is A and this is B, but it's still going to have, this is the same width on this side, this is the same length on this side. It's still going to be equal to each other. Okay, and so then it's easy after that in figuring out the answer. Because you'll calculate the answer, which would be 2 times 6, which is 12. Sorry, that's my dogs. And so it's 2 times 6 is 12. Okay, but remember you're dividing by 2, so you're still going to write your answer in here. And the answer is not 12, it's 12 divided by 2. Now punch that into your calculator, and that is 6. So it's 6, but is it just 6? No. And remember, this is area. So the area, check your formulas, the area is going to be blank square units. And what's the unit? Yes, it's inches at this time. So then it would be 12 divided by 2, which is 6 square inches. So that's what comes here. 6 square, write the word square. Look at your study sheet. So it's 12. It would be 6 square inches would be the answer here. How did I get that answer? Very simple. Just say area equals base times height divided by 2. Now, if you're struggling with this, just think of it this way. you could say your answer is length. Think of a rectangle, because remember, every right angle triangle is half of a rectangle. So a rectangle area is length and width. So if this is being difficult for you to grasp, base times height, don't. Just think length times width. So if you want to write length times width, that's fine, but no, it's only half of it, so that's why you divide by 2. So length times width divided by 2. And that can be your explanation. Please copy both, though, so you have this in your repertoire. Please copy this. Make sure you have it in repertoire. So I'm going to be going over after you finish this video, and you have to have all the work, okay? And please also take this home, and I'm going to repost again additional video, probably the same one, and have you study it at home and just kind of go over again, just so that you hear me explaining this, so that it really just hits home, so that you're like, wow, okay, I understand this. And this should, and if you pay attention and focus on the video and writing the notes, you should do very well. And not only that, but it might actually improve your ability to identify the conversion factors of meters and centimeters and kilometers and all of those different ones, capacity, mass. You'll be able to do all of them better if you refer back and refer to the examples and the formulas and actually copy the work. All right, thank you so much. Best of luck.